2024 Math Paper 2 is for the external and question 2c. Use geometrical instruments to construct triangle PQR in which PQ is equal to 10 centimeters, angle PQR is 50 degrees, and angle QR is 9 centimeters. So you always start with the base, and this is a practical topic, so you can practice with me. So of course, our base here is PQ, so we can start by drawing PQ, which is 10 centimeters. So my 10 centimeters will be here. Make sure that you are holding your pen or pencil, because I'm only using my pen because a pencil is not visible for videos. It is, but it's not very clear. So I'll put my pencil at 10, and then I can draw something like this. I can even draw it all the way to 0, but I like starting from 0 and then moving backwards until I meet the other line. Just make sure that you are holding your ruler firm so that it doesn't shake. And then after this, you can label it or you name it. Actually, this is PQ. Remember, in the question we have PQ, which is 10 centimeters. And then angle QPR, actually this is QP, and some R which should be on top is 50 degrees. So every time you see angles, you know that this guy comes in. So we want this angle to be 50 degrees. To do that, you can just put your protractor here like this. This part here, which is the center, should be at the far end of the line, like so, and then align this with this line like this. Yes, and then now you can put a dot, just a simple dot like this. You don't have to make something like this, it will mess your work up. So this angle is 50 degrees. This is where my 50 degrees angle is. I don't want to put it on the book for too long because this is a gel pen. And then what else? QR is 9 centimeters. So this is Q, and then my R is supposed to be somewhere here. So QR is 9 centimeters. One of my students, Nicholas, usually just draws a line which is 9 centimeters like this. And then he'll put this thing here. This is actually better because it's quite difficult to put your compass on your ruler like this. If you put it like this and then this one is slightly up, you may mess your work up. So you can just find a piece of paper, draw a line which is 9 centimeters, and then measure it like this. Yeah. So now I'll draw an arc from here which looks like this. So now, of course, you are holding your compass like this, not holding it like so. So now, the moment you draw this arc, then you know that this is always 9 centimeters from here because we used a 9 centimeters radius to draw this arc. So if I was to draw a line from here to there, from here to there, from here, anywhere along this arc, I'm getting 9 centimeters. So now what I'll do is, since I want to satisfy two conditions, one, this line here must be 9 centimeters, and then the second condition is this angle here must be 50 degrees. So in order for me to do that, I can just put my protractor here. Oh, of course, we've already done that, so you don't have to go there. So I'll draw a line from P passing through this and then touching this arc like that. Remember, this 50 degrees is angle QPR. So I can draw my line like this. Let me put it this side. Make sure you don't miss the point. So you are going all the way to the line. So the first condition has been satisfied. This angle is 50 degrees. You can even verify it. Yes. And then now this line must be 9 centimeters. So this will be easy because we already know that this arc is 9 centimeters from A. So I've slightly gone beyond the arc. When I'm drawing this, I should end on the arc. If you have a pencil, it's better to fix this. And then you can always verify that your QP, of course this is our P, this is our R. So your QR is 9 centimeters, and sure enough, it is for me. And then now, construct perpendicular bisectors of PR and PQ. So PR and PQ. So let me start with PQ, PR and PQ. Let me start with PQ. So to bisect PQ, I'll put my points at the far end of the line, at the vertex, and then with a radius more than half of PQ, I'll draw arcs on both sides of PQ. So I'll draw one arc here, and then without changing the radius, I'll draw another one there. Make sure you are holding your compass like this. You repeat the same thing this side. We have this and this. Make sure you don't miss the vertex. Then now you can draw your bisector, and make sure you don't miss the meeting point, because even a slight mistake here will mess your circle up, if any. So now after this, you can verify your bisector. This line was 10 centimeters and the bisector is at 5, although it's slightly off. It's not exactly at 5, probably because I'm using a pen. Yeah. And then we have PQ. Let's bisect PR. Let's bisect PR. So to bisect PR, we can do the same thing. I'll put my points at the far end of the two lines, which is known as the vertex, and then with any radius which is above half of PQ, I'll draw arcs this side and this side. So I can even use this same one like this, and then another one like that. And then I'll repeat the same thing here, making sure that I put my compass at the far end there. Draw an arc here, then another one there. If they are not meeting like this, extend it. I may have changed my radius. Okay. Yeah. something like this. And then now let's draw our bisectors. So you may not really have to make it this long. So mine seems to be connected because I used the same radius. You can always change. Of course, by changing, I don't mean the radius you use here, you change it when you are drawing arcs from there. No. When you are bisecting this side, you can change the radius like this and then make sure that you maintain that same radius. So now we can draw our perpendicular bisector, making sure that you don't miss the meeting point of the two arcs. So this one will be like so. And then of course you can verify your distance. So this was about 11 centimeters, and then I'm getting 5.5 here. This is acceptable because the bisector is basically just cutting this into equal parts. And then of course we have to name the meeting point O. Measure and write the length of OR. So OR, this distance here, measure and write down the length of OR. So to measure this distance, you can just use your ruler. Remember, O is the distance from, O is the meeting point of the two arcs. So this is O to R. This is about 5.7 for me. I'll verify the correct one when I work it out theoretically. So this is 5.7, I think. So 5.8 centimeters. That's my OR. You don't have to draw anything. They just asked you to measure the length from O to R. And then finally, I decided to add this as a bonus question. With center O and radius OP, draw a circle which touches P, Q, and R. So whether they say it touches P, Q, and R or all the vertices, they are referring to these three corners. So if your circle is to touch these three corners, then that circle should be outside. In case you are wondering, like, when do we draw a circle inside? When do we draw the circle outside? This is always stated in the question. So now I can use this as my radius, but of course before I draw I have to check that I'm not missing any point. So once I'm satisfied, I can proceed and draw my circle like this. So you don't have to force your tool, just hold it loosely using this part here, and then you can have your perfect circle like this. And then here is a simple task for you. You can try it out. So here it says which touches all the three vertices. So the question is still the same. When we say vertices or we say the points A, B, and C, we are referring to the same thing.